All right, 1.24, we're going to talk about combinations of functions. So that is function operations. We're going to be taking two functions, adding them together. We can subtract them, multiply them, and divide them. So it jumps right into the first example down below. If we're given function f, which is 2x minus 3, and g, which is x squared minus 1, we can add the two functions together. So when we add them, we have 2x minus 3 plus x squared minus 1. If you want to add them in parentheses, you can, but when you're adding, you can just drop the parentheses. From here, we just want to combine like terms. So we've got x squared plus 2x minus 4. It can be written as f of x plus g of x, or you might see it as f plus g of x. These mean the same thing. It's just two different ways of asking you to add them together. Next page, we're going to subtract them, multiply them, and divide them. So just so we can look back, f of x was 2x minus 3, and g of x is x squared minus 1. So when we subtract them, subtract f minus g, so f comes first, 2x minus 3. Now I'm subtracting the whole next term, so the whole g. I've got multiple terms in there, so I'm going to put it in parentheses. So this would be x squared minus 1. Now before we can just drop the parentheses, what would I have to do first? Distribute. We got to distribute that minus and then simplify. So minus x squared plus 1. Then we can combine our like terms and put it in standard form. So negative x squared plus 2x minus 2. And again, this could be written as f minus g of x. Next, we're multiplying them. So we have 2x minus 3 times g, which is x squared minus 1. How would I multiply these together? FOIL. So first outer, inner, less. So 2x times x squared would be 2x cubed. 2x times negative 1 is negative 2x minus 3x squared plus 3. So I'm going to rewrite it in standard form. We have 2x cubed minus 3x squared minus 2x plus 3. Now this one, you may also see it as f times g of x. Last step, we're dividing. So f goes on top. We've got 2x minus 3 over x squared minus 1. Always simplify if you can. Here we can't simplify, so we just leave it as this. What could x not equal here? If we stated our domain, what would x not be able to equal? Awesome. Can't have the denominator equal 0, so x can't equal positive or negative 1. So the domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. So when we're finding the domain, there's three things that we have to look out for. We have to find the domain of f, we have to find the domain of g, and we have to find the domain of the new function. Our domain of the combination functions, whether it's f plus g or f times g or f divided by g, would be the overlap of these three things. Let's take a look at example 1. Here it asks us to find f plus g of x, and then evaluate the sum when x is equal to 3. So let's start by finding f plus g. So we're going to add our two functions together. So we've got 2x plus 1 plus x squared plus 2x minus 1. Since we're just adding it, we're just going to combine our like terms together. So x squared plus 4x, and then the 1's cancel. So we got x squared plus 4x. Next, we're going to evaluate the sum when x is equal to 3. So we're just going to plug 3 into our x's. So f plus g of 3 would be 3 squared plus 4 times 3. So 9 plus 12, which would be 21. And then if this question asks for the domain, we have to check the domain of 3 things. We got to find the domain of f, the domain of g, and the domain of the new function. For f of x, I have 2x plus 1. Is there anything I could not plug into x here? So what would our domain be? All real numbers, so you could say from negative infinity to positive infinity. What about for g? Is there anything I can't plug into x here? It's also all real numbers, so negative infinity to positive infinity. And then my new function was x squared plus 4x. Is there anything I can't plug into x here? Nope. So our domain would be from negative infinity to positive infinity. So the overlap of these 3 things would be from negative infinity to positive infinity. Next, we're going to talk about compositions of functions. So it's a little bit different than combinations of functions. Composition is when we make up one function using the other one. So the order matters for these. If we have f of g of x, whatever's on the inside is going to go inside the other function. So I'm going to take that x plus 1 and plug it into the x. So x plus 1 squared. So this would be f of g of x. Simplify if you can. So here, let's simplify. X plus 1 squared, we'd have to FOIL it out. So we get x squared plus 2x plus 1. So you can say f of g of x, or it's also written sometimes as f of g of x. It's like a little fog. Now whatever's on the inside is going to come second here. So if we had f of g written the second way, the g, the second number, is what's going on the inside of f. It can also be read as f composed with g. So it's written again here that f of g of x can be written this way and as f, and then in parentheses g of x. It's not always going to be the case that f of g of x is equal to g of f of x. These are not going to be the same thing. Sometimes it can be, but not always. So the order that you plug one into the other matters. So just be careful. For the domain of a composition function, it's a little bit different than the domain of a combination function. Our domain here, we only have to check for 2 things. We got to check for the inside. So we want to check for the domain of the inside term, and then we want to check the domain of the new function. We're looking for the overlap of these 2. So in example 5, given f of x is x plus 2 and g of x is 4 minus x squared, find the following. So let's find f of g of x. What's going to go on the inside here? G of x. So I'm going to take g of x and plug it into the x in our f of x. So f of g of x is 4 minus x squared plus 2. So we just take our whole function g and we're plugging that into the x. Simplify if you can. So this would be negative x squared plus 6. Any questions here? In the next one, g of f of x, what goes on the inside? F. So we're going to take f, plug it into the x in g. So here we have 4 minus x plus 2 squared. Got to simplify. How do we simplify?
Foil.
We got a FOIL. So x squared plus 4x plus 4. Got to distribute the negative. So 4 minus x squared minus 4x minus 4. Combine like terms. Negative x squared minus 4x. So this would be g of f. Any questions here? If this one asked for the domain, let's find the domain of A for f of g. Two things that we have to look out for is the inside and the domain of the new function. What function's on the inside for A? G of x. What's our domain for g of x? Awesome. Negative infinity to positive infinity, all real numbers. Our new function for f of g of x was negative x squared plus 6. What's our domain here? All real numbers, negative infinity to positive infinity. So the overlap of these two would be from negative infinity to positive infinity. All right, let's look at example 6. So example 6 says the number n of bacteria in a refrigerated petri dish is given by this function, where T is the temperature of the food in degrees in Celsius. When the food is removed from refrigeration, the temperature of the food is given by T is in between 0 and 3. Find the composition n of T and interpret the meaning in its context. So let's find our composition. What's going to go on the inside? T of T. So we're going to take our second function here, plug it into the n function. So we've got 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. So anywhere we see a capital T in that first function, we want to take 4t plus 2 and plug it in. Now let's simplify. First, let's FOIL 4t plus 2 squared. Got to FOIL it out. That would give us 16t squared plus 16t plus 4. And this is still times 20. I'm going to distribute the negative 80. What's negative 80 times 4t? Negative 320t. And negative 80 times 2? Negative 160 plus 500. Now I'm going to distribute the 20 that we had out front. What's 20 times 16? What's 2 times 16? 32, so it'd be 320. 320t squared plus 320t plus, what's 4 times 20? 80 minus 320t minus 160 plus 500. All right, let's combine our like terms. So starting with 320t squared, 320t's cancel. So then we have 80 minus 160 would be negative 80. Negative 80 plus 500 would be 420. So n of t would be 320t squared plus 420. The second says find the time when the bacteria count reaches 2,000. So we're going to take our equation that we just found. What was it? 320t squared plus 420 and set it equal to 2,000. And solve. What would we do first to solve? Subtract 420. What's 2,000 minus 420? $1,580. What would we do next? Divide by 320. So we have t squared is equal to, let's simplify this fraction. They're both divisible by 10, so I can get rid of the zeros. And then they're also divisible by 2. So, bless you, 158 divided by 2 would be 79. And 32 divided by 2 would be 16. What do we do next? Square root both sides. So t is equal to square root 79 over 4. Why would I not put plus or minus here? Well, we're talking about time, but time can't be negative. And if we go back to, again, typically we would put plus or minus if we're solving, but can't have negative time. So it's just positive. Any questions here? So part 2 is just more practice with our combination and composition functions. So starting with example 1, let's do 1a. We want to find f of g of -1. Couple different things we could do first. You can find each one separately or find f of g of x first and then plug in -1. I'm going to find it separate. So let's find g of -1. So if I plug -1 into my g function, that'd be 4 minus -1 squared. So 4 minus 1 would be 3. So then we have to find f of 3. So we find f of whatever answer we just got. So f of 3 would be what? Square root 3. So that would be our answer. So f of g of -1 would be square root 3. Next, let's find f of g of x. What goes on the inside? G of x. So we're going to take 4 minus x squared, plug that into our x. So this would be the square root of 4 minus x squared. Simplify if you can. Here we can't simplify, so we just leave it. But let's find our domain. So we have a composition function. There's 2 things that we have to look out for when we're finding the domain. 1 is the inside. 2 is the whole new function. Which function was on the inside? G of x. What is our domain for g of x? If I have 4 minus x squared, what's our domain? All real numbers. So our domain of the inside would be from -infinity to positive infinity. Just so we can kind of see it, I'm going to put it on a number line. So all real numbers would be the whole number line. Now let's find our domain of the new function, the square root of 4 minus x squared. What can I not have when I have square roots? Can't have a negative under the square root. So we'd set whatever's under the square root greater than or equal to 0. So 4 minus x squared is greater than or equal to 0. We get 4 is greater than or equal to x squared. Take the square root. So we get x would be less than or equal to plus or minus 2, but when we get 2 answers, it kind of throws the inequality out the window. We got to check and see if we're talking about in between -2 and +2 or outside of -2 and +2. So if I put these on my number line, I've got -2 and +2. Would they be open or closed circles? Closed circles, because it's greater than or equal to. And now let's test a number. Sure. Plug in any number. I'll plug in a number 0. So we're testing in between. So we have 4 minus 0, which would be 4. Can I take the square root of 4? Yeah. So does in between work? Yes. Test outside if you want to too, just to be super sure that it's not going to work outside. If you plugged in 3, that's outside of your interval here, it's not going to work. Now our domain of our function is what overlaps between these two domains. What overlaps? Awesome. Bracket or parentheses? Bracket -2 to 2. Perfect. All right, next let's find g of f of x. So what's on the inside? F of x. We're going to take f of x, plug it into our g function. So here I have 4 minus the square root of x squared. Can we simplify? What simplifies? Awesome. Square root and squared cancels, so we're left with 4 minus x. Now let's find our domain. We have to check the domain of the inside and the domain of the whole new function. What function did we say was on the inside? F of x. So I'm going to go up top here. Let's find our domain of f of x. What can I not have under a square root? A negative. So I'd set whatever's under the square root greater than or equal to 0. So our domain for f would be x is greater than or equal to 0. So I'm going to go back down here. We said x is greater than or equal to 0. If I put that on a number line, we're talking about from 0 to infinity, because we're talking about greater than. Would it be an open or closed circle? Closed. So from 0 to infinity. Now let's talk about the domain of our new function. Our new function is 4 minus x. Is there anything I can't plug into x here? No. What would our domain for this be? Negative infinity to positive infinity, so all real numbers. What overlaps between these two? 0 to infinity. Bracket or parentheses? Bracket 0 to infinity. Just looking at the g of f function, it may look like our domain should be all real numbers because it's just 4 minus x. But you have to check the domain of the inside. So you always have to check for composition functions the domain of the inside and the domain of the whole new function. Now let's find d. What would you do first for d? Sure, we can start by plugging in -1 into f of x. So that would be the square root of -1. Can I take the square root of -1? No. So what do you think our answer here is? No solution, or undefined, or not real, whatever you want to say. No solution. It doesn't work out. Yes.
But can't you plug -1 to c?
You can, and so that's where you have to be careful. If you plugged in -1 into the x here, it'll work out. It'll give you 5. But is -1 in our domain? No, it's not. It's not from 0 to infinity. So that's why it's no solution. So that's why you have to be careful. I would recommend always just plugging it into the inside and then plugging that answer into the whole thing, because that way if it doesn't work, you'll catch it when you plug it into the inside. Or if you plug it into the new function, that g of f, and just plugged it in, make sure you check your domain. So we're going to use the graphs of f and g to evaluate the function. So our graph on the left is the graph of f. The graph on the right is the graph of g. So we want to find f minus g of 1. So we can find f of 1 and just subtract it from g of 1, or subtract it by g of 1. So what is f of 1? If we go to 1 on the x-axis, because what's in the parentheses is our x, what is our y? 2. So f of 1 is 2 minus, what's g of 1? 3. And 2 minus 3 would be? Negative 1. So f minus g of 1 would be negative 1. Let's do b. Here we have f divided by g of 2. So we want to find f of 2 divided by g of 2. What's f of 2? 0. What's g of 2? 2. What's 0 divided by 2? 0. Awesome. Next, we want to find f of g of 1. What would we start with here? G of 1. Start with the inside. What's g of 1? 3. Awesome. So now we want to find f of 3. What's f of 3? 2. So f of g of 1 would be 2. And then g of f of 3. What would we start with? F of 3, which would be 2. And then g of 2 would be 2.